Thank you very much for coming to the last talk of this year's NEOS conference. And as you've already seen on the schedule, Sebastian will show us some tricks of how to write unmaintainable code. And it's really funny for me that for other core team members are sitting first row to get some hints on how to improve NEOS and Flow even further for all our other community members interested in writing even more unmaintainable code, or less unmaintainable code, if we follow your advice, of reducing complexity. So, you know how it works with the NeosCon app. Please submit your questions, rate the talk, because afterwards, in the conference closing, we will award the best speaker of this year's NEOS conference. So please welcome on stage Sebastian Kurfu.
So hi everybody. So how do we actually write unmaintainable code? Well, we can ask AI. I'm an old school person, but I Googled, well, how do I write unmaintainable code? And the first hit is actually pretty good. It's from Roddy Green. It's a text, a really long blog post or long article a long time ago written. You see that from the serif font. I'm not sure if CSS was invented back then. Ensure a job for life. And it starts with naming. And it says, much of the skill in writing unmaintainable code is the art of naming variables and methods. They don't matter at all to the compiler. That gives you huge latitude to use them to befuddle the maintenance programmer. And they have some nice ideas like new uses for names for babies. Buy a copy of a baby naming book and you'll never be at loss for variable names. Fred is a wonderful name and easy to type. And if you're looking for an easy to type variable name, try ASDF or ADSF and AOEU with a DSK keyword. And it goes on. Accented letters. And actually in PHP, you know, UTF-8 support is supported in, I don't know, PHP 5 or something. So you can type your variable I or I acute if you like. I'm not sure if I've actually once worked with a French or a source code written in French that was really difficult for me as a non-French speaker. And it's really hard to distinguish. And the general advice is just use misleading names. You know, make sure that every method does a little bit more or less than the name suggests. So for an example, if a method which is named isValid should as a side effect also convert the number and store it in a database. And the problem is, I have already done that. You know, if you think closely, actually, we've all been guilty to that. You know, there's a method which is pure and clean and nice, and then the method does almost the right thing, and we just do this little tweak. You know, we just do this little call store to database, or this little send an email, or this little trick which changes state from some other object. That's the way. I've certainly done that quite a lot. Okay, so that was the Googling approach. So how can we write bad code? Actually, the article is really, really long. It's a really good read. I can very, very much recommend it. It has like 150 tricks on its sleeve and lots of things. It's really just the tip of the iceberg I've seen here. Okay, we can also ask us the inverse question, of course. How can we actually write good code? I mean, you know, unmaintainable code is the one thing, but we can also in science, we can also ask us the other question and reverse the answer. So how do we write good code? What actually is good code? And there are some things we can pretty easily agree on. So code must be very readable, reusable, consistent, whatever this means. But yeah, that's things I would say most of you would agree, right? Yeah? No? Okay, some. But then there are some things which are more debatable. For instance, we are all, or most of us are German speaking. Should we use an English or a German domain language? And I would say that is hard to decide, and it depends very much. And both sides have their pros and cons. Or let's take comments. Some say, we don't need any comments. Some say, we want lots of comments. Some say the code should be self-documenting. you know, and this is like different philosophies. Some say dry, some say yakni, some say gin tonic, I don't know. So that's like, it's not, it's not easy to define what actually is good code. But if you start thinking about this consciously, you are actually doing architecture. So you're on the way of doing architecture, and that's a good thing. And I'd like to take you on a journey how I started thinking about coding and I started thinking about architecture. And my personal journey started just around the year 2000. And just remember, that was the time where a really small band, a really unknown British band named Coldplay released their first album. Or in 2001, there was a really new device from Apple. It looked like this, the first iPod. And in 2001, the first Harry Potter film came out. And then another nice thing, in 2004, Facebook went online. And so this guy went online, and here you have this nice screenshots how Facebook looked like in the first version. And I remembered, you know, these layouts built with tables, and CSS was not really working, and these nice button shades from the browser. Oh, I almost forgot about the nice red banner on the left side. Yeah, beautiful, right? This nice icon with this, whatever this means. So, and this weird guy, which somehow is still around. So, and I personally can remember the Sylvester of the year 1999. I was 11 years old back then, and I was at a very unusual location for the Sylvester party because, do you remember the year 2000? And do you remember the year 2000 problem? Actually, my mother has been working and is still working at a chip manufacturer in Dresden at Infineon, and she was responsible and is responsible for the manufacturing execution system there. And there we had a lot of preparations, and they were very anxious about the year 2000 because they had no clue what would actually happen at this time. And so this is actually what were topics at our dinner table back then. I had no clue what it meant, but you know, that's what I heard about it. And so I was actually at the parking lot at Infineon at the New Year's Eve with my dad. My mother was working, and it turned out we were watching the fireworks over Dresden. It turned out nothing happened. It all worked out because it was prepared for. You know, they put a lot of effort in there and all these things. I myself personally, I was at the level, I was programming some basic in MS-DOS with this blue screen where you could beep the sound speaker of and I was programming alle meine Engine. Yeah, it worked. It was so cool. I was getting it working. Of course, I didn't think about architecture back then or anything like that, but I wanted to get things working. And I know by looking at people who learn programming, which I'm very fortunate to do with our people, which we help in this process, and our students at Sandstorm, I can follow this program along how people learn programming, and everybody is first trying to make it work, right? And trying to understand everything. And some years later, in 2005, I was 17, and I was becoming a Typo 3 developer, and I was still focused on making it work. And I wanted to make sure all the edge cases were covered, and I didn't think about any architecture. And the Typo 3 system has grown, like most open source software at the time, by the way. And we as a team saw that Typo 3 was used all over the place in lots of cases where it was not intended to be. So we started with the Flow framework from scratch, and suddenly we had a blank sheet of paper and we had to think about a lot of architecture decisions. And my personal influence back then were two main ingredients. The first one, you might know this one actually, it's an off by one arrow, by the way, so that's the 0th ingredient, Robert, because he figured out which books to read and which concepts to take. And he came up with these two books, and among some more. And the first one, Patterns of Enterprise Application Architecture by Martin Fowler. Who knows that book? Oh, most some. So that was released in 2002, and it was basically so it's still very readable and very relevant, even though it's 22 years old. And I think that is incredible. I mean, imagine that they have written that 22 years ago, and still lots of content is very relevant. What is it? What is in there? It's basically a collection of patterns for solving large-scale application design and framework design problems. So that means it's basically a Lego system of building a framework, and this is all in this book in many things. And there they explain there are different ways of doing object wiring and persistence and database transactions and all the things you might need. It's basically a how-to guide how to create a framework. And the second book, Domain-Driven Design, Tackling Complexity in the Heart of Software by Eric Evans. Who knows that book? Yeah, okay, a few. That is basically not focusing on the technical side, but it focuses on how can we solve or how can we transform the problem domain of the customer into code. And it gives us certain tools to do that. And this is also very relevant still. I actually read it like 1 year ago again, and it was like still, I discovered so many new things. So that is also what I can very much recommend. And so just to give you back in time, so these books were just released, we were reading them, just go back in your own time. And then there was this thing called Eclipse. You remember? And Eclipse was so cool because it was open source, and it was by IBM and all the big players. And they had this thing called OSGI. I don't know what it means, but it's basically the object model of Eclipse. And I was starting my studies, and OSGI was the hot, new, awesome thing. And there's this tutorial, getting started with OSGI, 45-minute read. I have no clue, like it's like 40 pages, and at the end you have a calculator running. Come on. That can't be the right thing to solve that. I'm sure this solves a lot of problems which the designer thought about, but not the problems I would like to have, actually. And Spring came out back then, and that was also interesting because Spring tried to solve this in a very smaller way and easier way, and this is where we got a lot of inspiration back then. And my personal goals back then, 15 years ago, were three things. Less lines of code, self-documenting code, and we would like to work with objects. So not imperatively anymore, but object-oriented, whatever that means. So what we did is we created a framework, and we created a templating engine, and we created a property mapper and an MVC framework. And do you remember Fluid? Yeah, some? And there in Fluid, there's this magic where you can put in some objects, and you map the objects with the forms, and there's a lot of magic going on behind the scenes, if you remember. So if there's a typing error because of a validation error in the post, the form is re-rendered, and so there's a lot of things going on to make sure you get validated forms. And that was magic. I was so happy when we solved this problem. And it was revolutionary back then because nobody else did that. So actually we solved our goals back then. But still it turned out in the process, I personally created a lot of bad code. And the worst one is certainly the property mapper. The property mapper is the component which takes the array structure coming from the HTTP request and creating an object out of that, which is then passed to the controller in the MVC framework. And it actually documents that as well. The property mapper transforms these simple types to objects or other simple types. It is used most prominently to map incoming HTTP requests to objects. And it will turn out that this most prominently will become a problem in the next 2 slides. Because then we had this concept called type converters, and there's a thing called the persistent object converter. The first 2 lines are still okay. If this is a string, it's a UUID, okay, we fetch it. If it's an array, we do some things. And then it starts getting crazy because you have to have some configuration options, and depending on where you and so on. So it starts to become complex, as you see from the documentation, and you don't need to read it, and I always have to look it up. It's pain. And then if you go some further, actually, there is an array converter, and it's like, huh? Why do we need that? I mean, array is an input format. Why do we convert to an array, actually? And then you read that. If the source is an array, it's returned unchanged. Okay. If the source is a string, it is converted depending on the format. If it's CSV, the CSV, you can configure the delimiter, and then you can basically parse the CSV through the array converter. Why? Why do we need to do that? Why, actually? And the thing is, nobody created that with bad intentions. Remember, it's basically created because, oh, actually, the property mapper is pretty much what I need. I just need it in the other direction, but it's pretty much the same thing. We'll just take it. And it gets even more crazy. So, for instance, there's a persistent object serializer in there, which is also a type converter, which takes a persistent object and converts it back, because we had the glorious idea to use that in the old Ember-based Neos UI back then, because it was almost what we needed. But I mean, in German there's the Spruch, knapp daneben ist auch vorbei. That is exactly the problem. This is exactly what is going wrong, and that led to lots and lots and lots of complexity. And there are some benefits still to that. I don't want to say this was all bad, because we prevented lots of security issues by that, SQL injection, CSRF, and so on. This was all built in, and this was also revolutionary. It took a long time until the other frameworks took that as a standard. But it had also some drawbacks, and the biggest drawback was the magic. It was difficult to follow what was actually going on if you didn't write it. So for me, it was pretty okay, I have to say. But I would say for everybody else, it was pain. And it was pain for me as well if I wasn't fully woken up, and and if I didn't sleep enough, it was pain. And if I had to do it at the evening, it was pain. So it was also pain for me. And then it was extensible, but not extensible. So that means it was only extensible at certain points if you really knew the intricacies of the system, and it was really hard to work with. So, but still we reached our goals. Remember, as little lines as possible of code. This is what our goal was, and this was the vehicle to get there. So it turns out, actually, the goal is probably the problem. So right now, my goals would rather be, instead of less lines of code, I would like to have explicit code. Instead of self-documenting code, I would like to have documented code. Just imagine if code has documentation. Instead of working with objects, I would like to have immutable and functional patterns. And we'll get to a bit what this all means now in the next part of the talk. So let's look at some elements of maintainable code, actually. And just remember, that's just above the surface of the iceberg. That's basically the part I can now talk and reflect about, but I'm sure there's a lot of things below the water surface. So things I'm not sure about, what I'm doing unconsciously in everybody of us, but by putting it together, we can learn from each other, and that's the nice thing. So I would personally say some key rules. So the first thing is basically compact code is good, but explicit is better than compact. So if it gets a little longer, but it is more explicit, that's good. And clear is a lot better than magic. So I would like to avoid these things like property mapper things. You just create a class somewhere, put some annotation on it. Spring is hell like that. In Spring, it's the case, you just put some class somewhere, annotate it in some way, the framework will somehow find it, and then configure some other object at the other part of the system somehow differently, and if you are lucky, it works. But it makes sense, of course, the way they build it, but it's just so implicit and so hard to follow. And I always ask myself a key question. What do I need myself to understand the code in 3 years from now or in 3 months from now? So the thing is, it's not something we do for others. It's something we do for ourselves, for our future selves, remember. And now come some guidelines, I think 8 or something, which I think, which I'm able to talk about. The first one is intrinsic similarity, which is really important for me. So that means code should be consistent to what is already there. The full thing should be coherent. You should not be able, if you open some code, you shouldn't be able to say, oh, actually, that's an early Robert Lemke, that's a late Bastian Weidelich, just by looking at the code and not looking at git blame. That would be bad, because that means the code is so individually written that it's not coherent at all, And this is an example, on the left is an example of the new content repository, and you see there is an intrinsic structure which is reappearing again and again just from the folder structure. And so you have like the different feature sets, and every feature has, or most features have commands, everything has events, some have exceptions, some have DTOs, and all have some kind of handler to handle it. Yeah, and there are some inconsistent names in there, of course. That's true. The thing is, if you do that, you might ask, well, if the rule is new code should be written the way old code was, how can we ever innovate? I mean, you know, because if the old code is bad and we create it the way it is like old code, that's not the full part of the equation. But still, it is important, I think, to keep that in mind as a baseline. Second, we need better ways to structure our code in detail, and I think immutability and pure functions are really, really good ideas there. So immutability is basically that the state in an object once it is created does not change. So you can roughly translate that with not having setters or any modification operations in your objects, right? And this looks totally trivial at first, but it has some really, really good benefits. That means that objects will never change, obviously. Objects will really never change. Really, no matter what you do, objects will not change. I'll get to what this means. They're easily comparable. It's easy to decide if it's the same object or not, because you can just compare all properties, because it's immutable. It's just everything in there. And because of that, it's easily composable. So that means it's like Lego bricks. These objects, if you have an immutable object and you want to wrap it in some bigger immutable object, the whole thing stays immutable. That looks trivial, but that's important because we want to build bigger and bigger systems out of Lego bricks and some functions to combine them. And if we do that on the state side, so on the data side of things, we can apply this idea of pure functions. Who knows what a pure function is? Quite some. Nice. So just to recap, it is a function without side effects. So that means it's a function in a mathematical sense where the output only depends on the input. That's the determinism part, and it should not do anything else than just calculating the result. So that means the function has just one exit, and that is the result, what is returned from the function. There's no email, no database persistence, nothing, no file writing or reading. That is all not pure anymore. And if you are able to model your business logic as pure functions, you have the benefits that you can actually compose them very flexibly. So if you say we have some pure functions A, B, C, D, whatever they do, and now you would like to create a calculate label function which takes in a node and gives back the node label. If you know that A, B, C, D are pure, you can easily compose them, and you know exactly the result will be exactly the same as before, no matter how you call this thing. You can easily cache the results because it's deterministic. Same input, same output. Easy rules, easy to follow, but really, really powerful. You can easily create great things from that because you can compose these together to build processing pipelines. You can do one step, the other one you can fork. You can do all kind of things you would like to do because you know your data will not change under the hood, and you know you can just plug in together. And my personal recommendation is to learn some functional programming. And by that, I don't mean learning like from this classical Haskell or whatever books, which teach you about functors or stuff. I have no clue what a functor is, but these kind of like things from the book. But learn the basics like filter, map, and reduce with callbacks based on like in JavaScript or in PHP with callback functions. And the second thing is learn or try to apply divide and conquer. And what is divide and conquer? It means you have a big problem to solve. You are able to slice it into smaller problems. You're able to solve the smaller problems, and then you can compose the big result from that back again. So, you know, going down, solving the individual parts, going up again, solve the whole problem. And if you're able to do that on a conceptual level, this fits extremely well with immutability and pure functions, because then you can just use your Lego bricks you have created, and by solving your problems, you will get more and more Lego bricks, which will all perfectly match with each other, and there will be no gaps between them. You can always use that, and this is extremely powerful. Right, functional programming. in a bit. The third one, libraries over frameworks. So what actually is the difference? Who has actually developed a framework here? I know there are some in the room. Yeah, a few ones. Yes. The idea of a framework is it basically tells you all about the world. It has a way of loading code, of loading configuration, of loading booting the system, of wiring the objects together. There are a lot of responsibilities a framework is usually doing, and your code lives inside there. So that's the right one, on the thing on the right side. So your code lives on the places the framework has left out, basically. But the framework is the wrapping thing. The framework is the thing which is booted as the first step. And a library, on the other hand, is the other way around. It's basically you have your code, and then you shell out to a library for certain functions, for logging, for instance, for emailing or these kind of things. And frameworks are very good and important for these things like wiring, configuration, dependency injection, but they are not good for business logic because they have inherently, they lead to extremely highly coupled code. On the other hand, libraries are really bad for wiring, like configuration, dependency injection, these kind of things, but libraries are really good at reusable, composable building blocks, algorithms, email sending logic, a content repository. You know, these are all building blocks you can use in your applications, and you can mix and match these two things. And in my opinion, the framework world is pretty much, you know, it's pretty clear what we expect today from a good framework. So I don't think that there will be so much innovation in there. There it's more about stability, performance, environment support, these kind of things. But innovation actually happens in libraries, which is good because this is where we can really plug and play together, and this is why the new content repository actually is a library and not a framework. Okay, so libraries over frameworks. Then the fourth one, tests and end-to-end tests. Who is actually writing tests on a daily basis? Yes, daily basis, weekly basis. Yearly basis. Once a year at, I don't know. Okay, so I totally understand you. In fact, it was the question I was most excited about, what the results would be. I was really interested in that. So, in fact, we at Sandstorm tried really, really hard to establish a culture for writing tests, and it took us quite some effort. So the first year we horribly failed. So everybody agreed, yeah, tests are really important. Yes, we need to do it. Yeah, but the budget is so small. No, tests, no. You know, that's the way it is. But the thing is, what we then did is we then switched the default. We were always telling, yes, please write tests. Yes, tests are the default, and you have to say why you cannot write tests. So we switched that around, and it was quite some work at the beginning, but now we are at a state where every project is by default tested, and for instance, the Ökokiste project, which Leo has demonstrated as the first talk here, it has end-to-end tests which actually use the shop and test certain things and say that the rendering works and that the importers work. And of course, writing the first test is really slow and clumsy. You know, writing the first test is always like, oh yeah, I have a blank sheet of paper, how do I get started? What do I all need? Or it's also complicated, do I really need to do it? I would like to program some code. No, it's a very stressful and painful period, obviously. But when you have the first one, creating the second one is a lot easier. Creating the third one is even easier, and so on. And at some point you end up at, I don't know, 16,000 lines of test code, like Bernhard, for the new content repository for moving nodes, which is really impressive, I think. And the thing is, tests really, really pay off. Really, really quickly. If you do it right, which means as little mocks as possible. If you want to know more, then rewatch Sebastian Bergmann's talk on that. But try just to fake external APIs, but then try to use the system as it is. And this becomes a lot easier if you use the approaches from before. Remember, immutability, pure functions, libraries over frameworks. Then this all fits together, and it makes testing a lot easier. Now we are moving somehow up the stack, reducing complexity. Complexity, it's such a difficult word, right? Everybody would agree on this term, right? But what actually is complexity? Sorry? Too complex. Yeah, what is complex? Yeah. Ah, that's like, come on, you can do better than that. That's a complex question. I won't take that one. Yeah, it's difficult to answer, right? Luckily, there's the last book I will show here, A Philosophy of Software Design by John Osterhout. Who does know that one? Ah, a few ones. Okay, so that's actually it's much more recent. He's I think a professor at some university from the Netherlands or so, and he has it's actually a pretty small book. So it's like I don't know, like 150 pages or so. It's really really readable, extremely recommended. That was one of the books. This book changed my life. I can really tell you. And what they say is basically saying complexity means all parts making it difficult to understand software or to change it. So that are the two aspects of it. Understanding or changing. Everything which makes that harder is complexity. And the good thing is, this book goes on and it also finds root causes of complexity. And the good news is there are only two root causes of complexity, according to the book, which is dependencies and obscurity. So dependencies is how big is the pile you depend on. So remember the dependency graph from Robert from the keynote, for instance, from what we depend on. That is one part. And obscurity, the other thing. Obscurity means how easy or hard is it to understand this code? And remember the property mapper back then, just a few slides ago, there was this nice sentence saying, yeah, it's mostly used for HTTP to object mapping. Mostly, yeah, this had this loophole, obscurity. There it is, in its pure form. And the book goes on, so we can tackle both. We can reduce dependencies or we can reduce obscurity. And this is actually what we would like to do now in the next part, in the last part of the talk. And the book has one interesting concept which really clicked for me, which is the concept of deep or shallow modules. What is that actually? A module can be anything from a function, can be a function, a class, a package, a related part of functionality. So everything where you can draw a box around, basically, and say this is some, and give it a name, some specific thing for a specific feature. It can be even a full application. And what they say is there can be deep modules, which mean you have a small interface and a big implementation. Best example is stuff like image recognition. You put in an image and you get back, this is a cat, you know? No clue however this found it out, but it's the totally easy output format, cat or dog. But what goes inside is really, 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 really complex, you know? But the interface is so small. You give it a binary data stream in form of an image, and there's one output from that. However, this is done. This is the essence of information hiding. On the other hand, shallow modules have a big interface and a small implementation. Hello, microservices, usually. Badly cut microservices is exactly that. If you do microservices right, you will end up with the left part, but it's incredibly hard to do that up front because we never know where the boundaries actually are. And by using microservices, we actually make it harder to change our software because we have this system boundary all over the place. It's like basically having a maze of walls around us and then trying to go from one route to the other. It cannot work, actually. And what we would like to do is try to create deep modules, a small interface and a big implementation. And you can, as said, apply that on any function, method, and so on. So this part reduces complexity if you follow this rule. Now we have to solve the obscurity problem. That was the other part of the equation. So how can we do that? I would say we can do that if we really stringently document why. And there's a really good blog post by Anti-Res, so that is the creator of the Redis cache system, which we use in Neos and in a lot of other systems, which is a really interesting and cool piece of software. And he has written a blog post 2003 days ago, writing system software, code comments, so it's also like 8 years old or something like that. It has 319,000 views. No, 319,000, yeah, something like that. And it's also a long comment, but I think the essence is this one. He talks about different kinds of comments, focuses on design comments. And it says, the design comment basically states how and why a given piece of code uses a certain algorithm, techniques, tricks, and implementation. How and why. It's a higher level overview of what you see implemented in the code. With such a background, reading the code will be simpler. Moreover, I tend to trust more code when I can find design notes. At least I know that some kind of explicit design phase happened at some point during the development process. Really good, you know? Not just starting to code somehow and somehow ending up at the result, but thinking before coding. It sounds obvious, I know, but you know, I've so often I've started my IDE and I'm like, oh yeah, I know somehow what I'm doing, but if I try to write it down beforehand, it helps me so much, even if it's just a few bullet points somewhere. And what I actually try is, I don't say you need to document everything, not at all. I'm just saying give some context and explain why. And for me personally, how does this how does this rule translate to code? My personal rule is every class needs a why comment, or it needs a link to a why comment. So the idea is with one click, you should find the why comment by one jump at most. And if you follow that rule, so you see, for instance, at the content repository class, it says, this is the main entry point to the system. Aha, important somehow, really important if you want to use that. What can you do with it? Where can you look for further details? And yeah, this is API, by the way. And the other one, node aggregate command handler, don't worry, it doesn't matter what it is, because it is internal. From user hand, you will use content repository handle to dispatch commands, and that is the link towards the place above, so we know exactly where we can actually find this kind of context. And if it's necessary, I'm personally a very visual type of person, so I think a lot in like graphics in front of my eye. So I really like to create some sketches or diagrams. I know this one is not up to date anymore, the new CR, but still it has served its purpose for the time. So because it helps me personally to visualize and have a clear mental model in my mind. And if I remember, we want to write code where I can easily jump back again 3 years later, and this is the mental model I need for me personally to get back into the mood so I can actually fix a problem. And if you use macOS, there's a small little tool called MonoDraw. It costs like, I don't know, 10 euros or something. It's really cheap. One time I can recommend it. That's what I use to create these kind of drawings, or this draw.io thing if it's like more complex things. But I try to do it inside the code if possible because it's just less friction. So don't be shy of creating sketches and diagrams. It is way quicker than usually expected in the first run. And now comes the dreaded one. Writing concepts. Who is regularly writing concepts? Like text, longer text, more than a page? Yeah, a few people, okay. I immensely struggled with that for a long time because I found it so hard to start. You know, a blank sheet of paper in front of you and it's like staring at you. I personally find that totally horrible, and it's so hard for me to start and overcome that. But luckily, we found another book, an ebook, by the way, Shape Up from Basecamp. It's an open book, so you can buy a print edition, but you can also just visit basecamp.com/shapeup or Google Shape Up, you will find it. This is a book explaining the project management method of Basecamp. And this is very specific to their company, so it's nothing you can, just take and apply one by one or anything. But it's interesting because it's pretty unconventional. It's very unconventional if you think about the classical Scrum-based, iteration-based thing. Because the problem is, do you know what I think the problem with Scrum is? Iterations are perfect, are really good. But there's one fundamental misconception, which is that most people think, oh, I do Scrum, I don't need any planning. Because I can always, every 2 weeks, I can change the direction again and again and again and again. And this is the way we create shitty software. If we just leave out the planning.
It works great for that purpose.
Yeah, if you want to create shitty software, exactly, that's true. Yeah, that's the way to create unmaintainable code. That's totally true. But it's not the creators of Scrum to blame, because I think for them it was totally obvious that of course you need to plan ahead. For them it was like, yeah, Of course, please do. But we just explain to you how you can organize your work on a daily basis and give you tools for that. You know, it is basically out of scope for Scrum to say something about concepts. But this was clear, or this became clear for me when reading that book. So that's how I can recommend it. And in the middle of this book, very, very much buried, there is a concept called a pitch. It doesn't really matter what this pitch is for, that's very specific to Basecamp, but it says there are these 5 ingredients we always want to include in a pitch. First, a problem statement. What do we actually want to solve? So that's not a new button on the website, not at all. It's a customer problem. It's something which creates value for somebody. And we need to be able to express that, to write this down. If we cannot write this down, we have a totally different problem. We cannot start coding. Remember obscurity. Appetite, that's also interesting. It's not the question how long does it take, but how much do we want to spend on the problem if we look at the problem. So that means, should we actually do this stuff if it takes 2 months to create a button? No, I actually only want to invest 1 day of work. And then we can see if we can create a solution within these constraints. So what this does is actually it constrains your solution space. Because I always have the problem, some customers always ask me, how expensive is this and that? And I'm like, well, it depends, you know. What do you want to do? And then we ask a lot of questions and so on. But I only want this web shop. I only want to sell some stuff on the internet, and and then this is where it starts. But by understanding the raw problem, we have 3 articles on the website, or we want to sell 100,000 articles a month, totally different problems, but both are a web shop on the front side. And by constraining the problem and the appetite, we are able to shape the solution space. And what we try to do is then going to the solution space, that's the third part, that's basically the concept. That's the classical concept, so to speak. So you wrote down a problem, an appetite, a solution, and then you can do rabbit holes or no-goes. That's for me like a bonus thing. So if I know in advance, this part of the code or this part of the system, we have to watch out there, then we try to write it down just to think it through. And what I do is I open this website probably, I don't know, every time I write a concept twice a week or something. I copy these 5 points down into an empty Google Doc or whatever, wherever, or Markdown document in my case. And then I just start writing underneath that, bullet points, text, whatever floats up. But this helps me overcome this initial fear of, blank sheet of paper and my brain is wiped out and I don't know. And I personally, we as a company do that at a single place, and because we are very source code driven, we do it at the source code level. So we have a notes or docs ordner in the folder in the project at the top level. And what works for us really well is doing it in a way that we always have a date in there at the beginning, so that you know how recent the thing is, and when it was the last, when the last big revision of a concept is, And then you need to know who the author is, and I mean we can use Git for that. You can just git blame it, and then you see exactly who has written what, and that's totally enough. And this is how this is actually from a production setup from us here, from a customer project. And you see lots of different concepts there, and the question is how long are these concepts? And that depends very much on the target audience. So some concepts are like this on the left side. This is the full concept, 15 lines of code. It's a concept about how we do secrets and security, or how we handle secrets in Ansible, so our recipes, and we just explain our naming convention. Okay, there's a Vault YAML file, and this is how we reference them, and the concept is basically 2 lines. Line 12 and 13. That's it. That is totally enough. On the right side, we have a much, much longer concept, and it's also totally fine. It's also fine if the concepts are incomplete. We don't have to strive for 100%, but they just have to serve the audience. If it's for your own self, I usually do the concept as until I have learned a lot of things about my system and my problem, so I can start solving the problem. So that is the point where I actually start doing that. If it's for another person, or if it's, for instance, for a customer and it will circulate at the customer's company, then it has to be a lot more verbose. My last big concept was like 50 pages of code, 50 pages in PDF printed for everything, just to take a really big customer business decision and technical decision there. So it really depends on the audience. And who uses a ticket system? Yet now comes the unpopular opinion, I hate ticket systems. I totally do. No, I don't hate them, but I hate the way they are used. Because usually people don't use a ticket system to track progress, but they usually use it to track feature wishes, bug fixes, or bug fix wishes, changes on the system. They use it as a communication means between the problem and the solution. And what happens so often is, as a customer, I want a fast website. Solution, make my website fast, 3PT. And it has happened so often to me that we have created a long concept sometime, then somebody has sliced it into tickets. This has taken a few months because people had other things to do. And then we got back, then somebody implemented it, and then we had to review it. And we were like, oh, wait a second, like 1 year ago, we've written this concept, pull out the concept, the code there and the concept there, that's totally different things. And this is imminent because a ticket usually is not as long as a concept. It's always an extract from that. And because what we usually do is we write a concept in our head or wherever, and then we put the things into tickets, but we lose context. And that is a problem. Context is the thing we are looking for because it gives us a mental frame, a mental model to think about a certain problem. So I don't hate tickets at all as a general principle, but I would love to have a ticket saying, you know, link to this concept and please implement these 3 things from that. That is totally cool, you know, because it's one click again to the context and to understand why are we actually solving that, how much are we able to invest or want to invest for that, and how is the full path to the solution. And if I'm not able to draw the path, I won't succeed in reaching the goal. Right. And then there's the last one that's not so controversial, but also really nice, review and discuss. I personally like synchronous code reviews a lot because we have done a lot of asynchronous code reviews in our company first, and it always turned out to be weird because you get this finished, polished pull request, and of course you can say, oh yeah, the spacing is not right or whatever, you know, these things which don't really matter. But if you have a conceptual problem, then you can basically say, well, just scrap it and start from scratch. That is really hard to tell somebody who has spent so much work on it, right? And in turn, when we discuss things, it is a lot easier to figure that out because we can just ask, well, what did you think? So we sit together at the same desk or virtually, and somebody is driving through the code and like explains to me what he's doing, and by doing that, they'll usually have ideas. Like, oh yeah, I should do this differently. Maybe we should do it this way. And I'm usually like, yeah, that sounds good. I have no clue, but and that is enough. That's what we want, right? I mean, the solution is in our heads. We just have to unpeel it, so to speak. We have to peel the orange or however the image is. I don't know, to get the actual good idea. And also discussing concepts is where I personally learned so much about myself, about a certain problem domain, about the other person I'm discussing with. So that's also what I can really recommend. Right. So to sum it up, we started, how can we actually write unmaintainable code? I hope I left some clues in your heads and I have told you where you can look up really, really cool more ideas. Emojis, by the way, Unicode and so on. We've unprintable characters and so on. We'll come to that. You can watch that. We've seen what is good code, and we've also seen what is bad code in hindsight. Remember the property mapper. It was good with the goals we created initially, but the goals have changed. And in the end, we went through the different ideas or ways I currently can express about good code. And I would like to invite you to that we start a discussion about that together. And I would like to invite you to really consciously think about these kind of things. So, thank you for listening.
Thank you very much, Sebastian. As this is the last talk of the conference, I have 2 comments to share, basically, and 1 question right now. So first of all, thank you everybody who used the question function of the app to submit praise to the speakers. We do relay that to everyone, so here again, there's praise in here. Great talk. Awesome.
Thank you.
A second one, Mark Henry found some inconsistencies that I think he already created an issue for and will help work on in the future. So thank you very much, Mark Henry. And the question is, are there tools besides Behat you recommend for end-to-end testing?
For end-to-end testing, so Behat is a tool which makes these executable specifications, right? Where you write text basically, and then it's a regular expression for every line, and this creates, or this is how the code is run. That's a pretty easy tool actually, and you don't need Behat if you're a very disciplined programmer, because then you can actually also do that with abstractions and code and so on. But I personally, I'm a very lazy programmer, and this means if I have a test case and I want to have a different test case, almost like the first one, I usually copy paste and start modifying because it's a quicker way to the goal. And by doing that, I lose intention because I lose context and lose like the why. I lose the why when creating this test. And by using Behat, it forces me to do this, to think about my language and think about what problem am I actually solving. So this is why I personally would recommend it, but it's not about a tool, it's more about the mindset you are in. I think that's the important thing.
All right, Sebastian, thank you very much for your talk.